Hello, everyone. Thank you for inviting me to talk at Lightup Virtual Conference. I'm really honored and really happy to contribute to this noble effort. And my today's presentation topic is a new future with AI tools. Today we'll talk about we are hearing a lot of things about AI, how it's going to rule the world, how it's going to change the world. But we will take a step back and think about all the aspects, like how can we incorporate AI in our business? What is the future is looking like, and how we are using AI in our today's daily life. So before I jump into my presentation, I would love to give a small intro of myself. I'm Rahat Yasir, lead AI developer at Auxidia. It's been 8 to 10 years I'm working in this AI industry in different as initially I worked as a researcher at a P2IRC Research Institute, and then last few years I'm working at different big organizations and taking their AI models into production and productionalizing them so that people can use them like those AI model or research. Uh, and at the same time, I'm a Microsoft MVP in AI. It's been like 6 years. I am Microsoft Most Valuable Professional, and back in 2018, I got the Canada's top software developer 30 under 30. So that's like a small intro about myself. As I'm not showing my camera, that's why I just like put a photo of mine on the slide, so that you guys can get the idea that I'm not an AI or bot. I'm just a human, just like you guys. Okay. So I wanted to put this slide, I'm gonna urge everyone to donate as much as you can. So as this cause is really noble, and we are supporting to fight something which is like beyond our that we can't even imagine where it's going. And I'm also gonna thank to all the sponsors to support this noble cause and making it happen in a week. Okay, so now the question is, why is AI important? So we are hearing a lot of hypes and like a lot of things from last few years about AI, but is it actually true? So if we look back at different waves in our IT business or IT industry, then we can see that there was the wave of software development, desktop software development. Then we saw web applications or website. Then we saw mobile. Then IoT and AI is here today. So back in 2008, 9 or 10, when web application, desktop software were ruling the industry, then mobile application came. A lot of people were talking about like, okay, who is going to use mobile apps? Who is going to use this mobile? No one is going to do that. But now, you cannot think your life without mobile apps. Like you are using mobile apps everywhere, like from banking transaction to see the weather to have conversations to do anything actually, like have communication through different social media. So that's where the AI is today. Like a lot of people maybe are saying, okay, AI is just a hype, it's not, nothing is going to happen, like making jokes at the same time. But this is like AI is actually like empowering all the industries that we have. So sometime some of the industry leaders thinks that AI is going to be bigger than internet. Why? Those mobile web or like desktop software, they were just like a single media. But AI, what it's doing, it's not a single media or single platform. It is actually connecting all the platforms that we have and empowering them so that they can do beyond what they're supposed to do. So that is the reason why AI is going to be big in future. And as a business leader or someone who is involved in IT business, this is the right time to invest, and this is the right time to get the competitive edge. So again, is the hype real? As we are saying a lot, hearing a lot of things all on a sudden. Yes, the hype is real, but at the same time, there are some reasons why we are getting all the hype all on a sudden. So if we look back of 5, 10, or 15 or 30 years back, so all the AI algorithms that we are using today, suppose take the example of neural network or decision tree, they existed back in 1990s. So why all of a sudden like a lot of hype we are hearing? The main reason is the computational power, computational capacity, cloud, and GPUs. So we started to like there was a like a big era of computational like GPUs started from 2014-15. We were not able to like process lots of data. We had very, like a lot of like computational limitations and data handling limitations. That's why we were unable to use those like algorithms to the fullest like of their capacity. But what happened with the like rise of all those computational cloud resources, we can leverage like the entire amount of data that we have. We can process more, we can find out more patterns, we can know a lot of other things. So suppose if I just give you an example, when Facebook first launched that photo tagging option on Facebook back in 2011-12, that time the accuracy rate was really low, 60, 64, 65%. It was giving us lots of wrong information. We had to manually tag them to our friends. But today the accuracy rate is so high that it's like almost 95, 98%, and it's automatic. We don't need to like tag it manually. It's rarely making any mistake. So what is happening? So it's the same algorithm. Yes, they have updated the algorithm, used new like fine tuning process and like with, but it can handle more data, find out more pattern, and they have trained it for years and years. That is the reason why the accuracy rate is really high, and it is actually used in our daily life these days. So that's why the hype is real, and it started like 5 to 6 years ago because of the growth of all the the rise of all the cloud and computational capabilities. Now, the question could be like why the AI is important, like how big the number is, how big the market is. AI market, the global AI market was $10.4 billion, but by 2025, like it is expected that the AI market is going to be $126 billion. So in that sense, we are just scratching the surface right now, and the like the full development and the interface is just like is ahead of us. And if we look at the like the productivity, so it is also said that AI can increase our business productivity by 40%. So all those people that are hearing this talk today, like you can ask, like, okay, some of you are from like different backgrounds, from like a healthcare, agriculture, IT, or something else. So how AI can increase the productivity of all kind of businesses by 40%? So what is happening here is like AI can increase the business productivity by 40% because based on the growth, the forecast, new features, bringing new capabilities, like to give you the competitive edge. So how? So suppose like you have a software that is in production right now, and a lot of people are using it. So what is happening? With the AI and data science capabilities, you can do more processing. You can find out like different kind of like behavior pattern of your users. You can find out which features users are using the most, and based on those you can empower them, you can focus more, and you can change the way they are like interacting with the system so that they feel more comfortable. They stay with you, they don't move like and start to use your all the tools of your competitor. So that is the reason, and you can also like bring more features, and you can also offer new like tools like based on the data science and AI capabilities. So that's what is giving you the competitive edge in the market, and it is keeping you ahead from your like competitors. So that's how it is like actually increasing business productivity. But at the same time, it's also like bringing lots of automation, and those automation can like save a lot of time and resources and money too. And the last one is, as a business leader, if you're thinking, is it the right time to invest on AI or not? Then my answer is this one. Only 15% of enterprises are using AI as of today, but 30%, 31% are expected to add it over the next 12 months. So if you're thinking ahead, as a lot of things are happening in the COVID days, you're also maybe rethinking about your like focus, your future, your current career. But I can also suggest you should also like considering having data science and AI based knowledge. And you can see that next 2 3 years and 2 to 3 years are going to be very crucial, and you will get lots of opportunity to evolve as a leader in this domain too. And the last one is COVID. As we all know that COVID has impacted our life, and in general, like everyone is got impacted because of that. So is AI industry got impacted as well? Yes and no. So what is happening? Like from our like we did some research, like kind of like survey, and like after talking to a lot of like people from our industry, we got to know that only 3 to 5% of our like fellow colleagues lost their job because of COVID, but because of the COVID-19 situation, AI industry is seeing more investment because AI is bringing more automation, like all those like data visualization and all those like investment in the manufacturing industry, healthcare industry, construction, because we can have like less like interaction these days, physical interaction or human interaction. So AI is becoming more important. And even like what we have noticed that AI healthcare spending is increasing for from 463 million to 2 billion by 2023 because of COVID. Even the construction industry is like getting a 1.13 billion dollar boost because of this COVID, because more companies are bringing more automation like to fight and avoid all the like interaction through COVID because of COVID. So yes, AI industry got impacted a bit, but at the same time, it is getting more investment, more like attention because of COVID. Now the thing is, like as a business leader or someone from like IT industry who is working as a software developer, web developer, or some other like without some other tools, how important it is to like what are the things that you need to know, like what are the must known things. So the key information about AI that you need to know are these keywords, like what is AI, like artificial intelligence, machine learning, deep learning, data science. For someone from like non-data science, like a non-AI background, it may look like same. Okay, all of them are like the buzzwords are the same thing, but for someone from the like IT industry or from this domain, they are those words are very like different from each other. So if I just like give an example that will like clear your vision. So AI. So what is AI? So it's just like we as a programmer, we are writing programs always, but when we are able to give the cognitive capability to our programs to take decisions just like humans based on different experiences and data, that is called artificially intelligent. So what does it mean? Suppose cognitive capabilities are seeing, hearing, and understanding through different languages. So from different contribution application, finding a human, understanding what we are saying, having interaction, those capabilities, when your software has those capabilities, it means it has the AI understanding or artificially intelligent capability. So what are the AI domain and boundaries, and where are the use cases of AI? So if we look back, like all over, like our like ourselves, like where we are today, we can see our life is completely surrounded by AI. So if I just give you some examples, if you are using a mobile like iPhone or Android, and if you have a facial recognition based lock screen app or something like that, then you are using AI, which is a complete example of like contribution. If you are having like using Alexa or Google Home or Siri or like Cortana, then you are having conversation, which is a natural language processing through those chatbots. It is a part of AI. It's really hard to find someone these days who hasn't used Google search engine or Bing search engine, and that is information retrieval AI. You did like shopping, online shopping using Amazon or other like online like e-commerce sites. So whenever you do some shopping, if you buy like a red t-shirt, then the next moment you see, hey, you should like some suggestion regarding you should buy this black pant as well, which will go with your red t-shirt. So it's like a like personalized shopping or information filtering or recommendation system. That is also AI. So if you have insurance, you're paying $10, $15 for your car insurance or health insurance. Those numbers that are coming are actually predictive analysis. Those are insurance premium like detection or like prediction. That are also like examples of AI models. Robotics, we know we have seen them in different movies or like in our real life. The robot brains of taking decisions are actually AI. The utility demand. Suppose like if like I live in Montreal, like Quebec. So our Hydro Quebec, like at the beginning of the year, they based on our last 1 year of electricity consumption, they tell us, hey, next 1 year, every month you need to pay $30 for like electricity, something like that. So this utility demand, it does forecast based on the people, based on the usage of last few years, and all the like decisions. So this decision analysis is also a perfect example of AI. The fraud detection, if you are doing some kind of like unusual transaction and then you get a message, hey, is that you from your bank that who has done this unusual transaction? So that is a perfect model of fraud detection. That is anomaly detection model. So that is a part of AI. And the surveillance, we see a lot of like AI models or like that with different surveillance cameras that can identify humans, that can identify there is any how many people got in, how many people got out automatically, to do some kind of identifying all the information about the activities of the work site or of the construction site. So that kind of surveillance is done by video processing. That is another example of AI. So if you sit back and see, all the examples that I have given are, you are using them almost every day, and all of them are the perfect examples of AI, and that's how our life is surrounded by AI. So it's not just a hype, it's not just something like buzzwords. People are using it, people, and you are also using it, but it's just like for your own business, you need to embrace it and like make a plan for next few years. How can you incorporate that one? Now the thing is, the two other things, machine learning and deep learning. For some people, they may think they're the same, but actually they're different. Machine learning is a subdomain of artificial intelligence, and deep learning is another subdomain of machine learning. So what is happening? Suppose you have designed a model that can detect car to identify it's a car or not. So you have collected all the images, and then in case of machine learning, this is a machine learning approach. A human needs to come up with different feature engineering approaches, like feature extraction. It will based on the human written code. From the image, you will extract how many doors are there, how many wheels are there, what is the shape of the image or the object. And based on those 8 to 10 or 15 features, like it takes a classification based decision, like whether it's a car or not. But in deep learning, there is no human involvement. What is happening? You are just giving all the images, and deep learning is finding out all the pattern by itself, and then it is telling, hey, based on the images that you have provided, this is the pattern it has learned automatically, and this is a car or this is not a car. So the difference between the two key difference between machine learning and deep learning is machine learning needs a human in the loop. Deep learning doesn't need a human in the loop, other than like helping with the data or data cleaning. And in case of machine learning, you need less data to take a decision or come up with a good model. But in case of deep learning, you need lots of data, because you are automatically letting the model to find out the pattern, finding out all the features by itself. Okay, let's move forward. And then what is the data science then? If you look at the diagram, then you can see data science is actually overlapping in all the like domains: artificial intelligence, machine learning, deep learning. Data science is the science of learning about the data, knowing the data, finding different patterns of the data. So what does it mean? So these are the two examples of two data frames. So what is happening here in the first data frame, based on the transaction, it's a financial transaction based data. It is telling like the data science based model is finding like these are the similar transaction, they're safe. But out of all the transaction, there was one transaction on Wednesday which looked like not unusual. That's why it has like tagged that, hey, it's an unusual transaction. Maybe it's not you. Maybe it's like a fraud detection model has detected that one. So finding out this kind of like unusual similarities on like unusual cases or fraud cases, this is the actual task of like data science. But again, to design deep learning, machine learning models, you will have to have like data science based approaches to clean the data, process the data, and do all the issues. Okay, these were the differences and like domains of like artificial intelligence, machine learning, deep learning, and data science. So like we got to know about the differences and like what is happening in the market. So now we need to know about the data. So as we all know that for data science and AI, we need a lot of data. So what does it mean? And as a business owner or as a software engineer, if you have data, if you're handling or dealing with data, what does that mean? Like, what is that data representing? So there are three categories of data. One is category one, category two, and category three. All the data frame, all the single values or text or single numbers on a like CSV or like that kind of like a representation are called category one data. So 60% of the models in North America that are making money that are from category one. So what are the examples? The insurance premium prediction, the regressional analysis, predicting it's a fraud case or not, it's an unusual transaction or not. Those are like prediction, regression, and like classification are representing category one data. So as someone who is like planning to learn AI, so I will suggest you like invest as much as you can in category one because most of the models are in production are from that category. Then we have category two data. So it is mostly audio and conversation. So what does it mean by audio and conversation? So we most of us have used Alexa or even Cortana or even Google Home in our daily life. So 25% or even like chatbots, those are the complete like a perfect example of category 2 data. So 25% of the models that are making money in production in North America are from category 2. So if I give you an example, whenever we are saying to Alexa that, hey Alexa, what is the temperature in Montreal tomorrow? So what it does, it takes the like audio speech and then it converts into text, and then it finds out the key phrases. Those in this line, the key phrases are temperature, like is an action. The Montreal is a location, and like tomorrow is the state. So what is the temperature of Montreal tomorrow? So it just takes three entities from the entire sentence, and based on those action, state, and action state and the time, it is trying to and to find out like the what is the like from its database what is the temperature tomorrow. Then it will return tomorrow's temperature in Montreal is 22 degrees Celsius. So something like that. That's how the conversation works in category 2 data. And the category 3 data, we all are familiar with all the video processing, image processing, or image like facial recognition. So they are image and video based processing are category 3 data. So 15% of the models in North America are from category 3. One interesting thing that I want to share is the complexity and the resource allocation and the needed resource needed to design those models also increases from category 1 to category 3. So it means you need more data in category 3, you need more resources, you need more pattern. You need less data in category 1, and you need less pattern and like rest resources compared to category 2 and 3 for category 1. So these are the category 1 to 3. Whatever AI models we are designing or we are planning to design, they will be from one of this category, category 1, 2, 3. Now, if you are like a business leader or like a software developer, if you're like and you're planning to like switch your career or like add new expertise in your career, then how you're gonna do? So as a business leader, in your software development team, the typical roles that you have are front-end developers, back-end developers, full-stack developers, database admin, software architect, and like team lead and Q&A, like who are software tester. So these are the common rules that like the roles that you have in your company or in your team. So do you think these roles are enough to does all the jobs of data science and AI? Let's see. So this is like the next slide is representing the complete machine learning pipeline. So what does it mean complete? Complete machine learning. For any kind of like machine learning or data science based model designing, we need to go through all those steps. So this is where your raw data are. You do the data acquisition. Once you do the data acquisition, you will have to do data processing, data feature extraction, scaling, normalizing all the data, data wrangling. Once the data is ready to be used in the model, then you need to create the model. You need to use different kind of like machine learning algorithm to create the model that goes with your like machine like the approach, and then you will validate the model, do hyperparameter tuning, and if you are comfortable with the accuracy, with the result, with everything, with the outcome, then you are taking this model and deploying it. So do you think all the like seven like um, all the like seven roles that you see in your traditional software development team, front end, back end, full stack, database, software architect, team lead, or like even QA, are capable of doing this operation? Not really. So that's why like you need your like developers needs to learn like up the game. They need to learn something extra. They need to know something extra to like to be considered as like a data science developer, or like to contribute in this domain. So okay, so what are the roles that have evolved in the industry with the evolvement of AI and machine learning and data science application designing? So what we have seen that these are the 8 roles that have like that has evolved in the industry in last few years. So some people may think, okay, the data science and like all of them are looks like the same one, but not really. Their job roles, their capabilities, their categories, all are different. So the data scientist, what his task is, he is the one who is finding the pattern of the data, extracting meaning of the data. Data engineer, he's the one who is preparing the data, doing all the plumbing so that data scientists can use that data. Big data engineer, if you have multiple streams of data, then like someone needs to design the pipeline, and so that your application can hold that much data, can process that much data. So that is done by the big data engineer. Data visualization developer, before you design anything, before you do any kind of modeling, first what you need to do is you need to find out like this that data has any value or not, has any pattern or not. Or even like during this COVID time, we all are seeing all the like graphs, all the like all kind of like different kind of charts like about COVID and like infection. So those are done by data visualization developers, so that you can find out patterns. You know, like this data has value or not, what is happening. Then the machine learning scientists. All the algorithms that we are using are actually designed by machine learning scientists or machine learning researchers. So they are the one who takes your data, sometimes build custom models, custom application for your business or for your need. Then AI and machine learning engineer, this is the best role for your like full stack developer or like your software engineer to be like AI or machine learning engineer. What they can do, they have the software engineering experience, they have the software experience knowledge, they can learn about like learn different platform or different like frameworks, and at the same time they can learn how to use those like algorithms, how to use like do those training, handle that kind of like data, and then evolve as an AI machine learning engineer who like takes care of the training, who like deploys that model in the production and incorporates that model with your existing web or mobile application. So that is the best role for your like for your team member. But at the same time, rest of the two are business intelligence engineer. So lots of BIs and like incorporation are done by business intelligence engineer to find out different patterns of your data. And the AI architect, it's also like a very dream role. So just like a solution architect, application architect, or enterprise architect, if you have a big application and having like adding lots of like AI models in your web or mobile, then you need to know how your application will handle that much data, handle that much load of like a prediction and inferencing. The AI architect will be the one who will design or like overall plan or the architecture that like through which you can add like AI models with your existing system. So these are the roles that have evolved in the like in the industry over last a few years: data scientist, data engineer, big data engineer, data visualization developer, machine learning scientist, AI or machine learning engineer, business intelligence engineer, and AI architect. So they're very different from traditional roles, but like as market is going forward, these like roles will have more value and like more jobs in the market as well. Now, as we know that traditional software development roles are not enough for our like AI and like data science based application designing, but you can also ask, okay, what is the like a perfect end-to-end data science or machine learning life cycle looks like. So this is the complete example of like end-to-end machine learning and data science life cycle. There are, we can like overall like divide it into three different like categories. First one is preparing the data. Second one is building and training the model. Third one is deploying and predicting based on the model. Okay, so what is happening here? First, like you have the data storage from different streams, and then you are doing the data ingestion. After doing the data ingestion, on the preparing the data, you're doing as usual like lots of data transformation, data validation, data processing, data featureization. So you can ask, what does it mean by all those like data transformation? Suppose you are designing an insurance model that is predicting how much, what will be the insurance discount like someone will get, because it's a COVID time, everyone is not driving, everyone is mostly like because of the lockdown is staying home. So why would they pay the exact amount of insurance for your auto insurance? So suppose you have two types of data. One is like you mostly user data. So on the user table, you have one data of date of birth. So that date of birth is an infinite range. So it's like someone can like born in like 2000 or even 1970s or 1950s. It's hard to group them based on just date of birth. So, but it's easier for a model to process the data and group them based on the age group. So taking the date of birth, converting them into like finding out whether it's like a string format or what is the format of that column, and then converting it into date time format, and then like subtracting that date of birth from today's date to find out what is the age of that user is called data transformation, data processing. And the value that you are doing after all the like transformation, that exact age, which is 55 or 45 or 25, is called data featureization. Okay, once you do the data featureization, you have suppose two types of data. One like two user data. One is someone who is using your like insurance from last 10 years, who is 45 years old, and another person is using your insurance from last 1 year, but is 20 years old. Okay, the first one, who is a very experienced driver, have never incorporated any accident, but the second one, who is a new driver, had like 3 accidents in last like 3 years. Okay, or 1 year. Now you will have to like select the right algorithm here. As you have the data, you will select the like best algorithm. When you're doing the algorithm selection, it's like a regressional like based like problem where you're predicting what will be the like optimal insurance discount for these users. So there are so many like hundreds of like regressional models in the market. So you will have to, your data scientist or your like machine learning engineer will have to find out which is going to be the best model or algorithm for this specific problem. Sometimes you need to like train multiple models to see impact of different kind of like data processing and model based calculation to select the best model. Once you do the model training, then you will have to do the hyperparameter tuning. You can also ask like, what does it mean by model training? And after the training, we are just getting a binary file. What is this? So what is happening based on the model training? The data that you have provided, the model actually we just crawl through that data, all the data frame, and find out different kind of leaves, nodes, trees of a full comprehensive representation of that of the data, and then we store that representation in a a binary file. It could be a bkl file or Python or something like that. And whenever there is a new data, we just go through that representation or that kind of like a tree to find out what will be the value of that prediction. So that's what model training is. It's just like whatever data that we are providing, it's like converting that data into like a complete tree-based representation or this kind of like a binary representation that crawls through the data. And hyperparameter tuning, different algorithms have different lambda values, different kind of like hyperparameter. We need to train them, tune them. Sometimes we need to come up with different combinations of hyperparameter to find out the best combination, and select the best one that is giving you the best result. Okay, once you have trained the model, once you done all the hyperparameter tuning, you need to like test the model, like how much resource it's taking, how much like time it is taking to predict that one, and how good or bad the model is. Whenever you're designing any model, you need to divide the data into three parts. One is 70% is as a training data, 15% as validation data, and 15% for testing data. So you will use that testing data to test the accuracy of your model, whether it's giving garbage values or not. And once you validate the model with the resource allocation and everything else, then you're comfortable. Okay, this model is not garbage, it's giving you good result. Good result, what does it mean? So suppose that old user of your insurance premium who is 45 years old, if he's getting 30% discount, and the new user who had like had few accident and using your insurance premium from last 2 years got like 10% discount, then it's valid, it's justifiable. Then you can say, okay, it's not giving garbage result, it's giving like right result. Then you can input it in production. But if your model is giving 30% discount for the new user and 10% discount for the old user, then you can tell, like, you can see like, okay, there is something wrong, that there is issue with the data, and the data, like the model is not properly trained. So you cannot put it in production. Then you are putting the model in deployment. So what does it mean by deploying? We take the binary model, wrap it in an API, put it in a container, and then host that container, Docker container, in a like production environment. And then we just expose that API to our web or mobile application, so that from our web or mobile application, we just get the API call, we just process that one, and give the response of like the discount number, like 15, 20, 30. So this is the approach of model deployment. Now you can tell how many models you can have in one mobile or web application. You can have thousands of models. Suppose like one of the example is one of the very like prominent oil company in US. They have 9,000 models in production. So like you can see like how like important it is to automate that entire approach. Otherwise, it would have taken them like days and years to take the do all the deployment training and deploy it in production environment and incorporate that one with web and mobile applications. And if you have lots of data, you can also do like batch prediction to annotate them and like do other processing. And the last one in the end-to-end data science approach is model monitoring. So what does it mean by model monitoring, and why do you need to monitor the model? So models are valid for certain time, and after that it starts to give like unreasonable or garbage results. So suppose that insurance model that you have trained or designed is giving the right result today, but 1 year from now on, if that experienced driver like have like experience or encounter 3 or 4 accident where the new driver didn't have any accident. In that case, if you're giving the same kind of like result, like 30% discount for the new driver, like old driver, and 10% discount for the old driver, then that is unfair. You need to monitor when it's giving garbage values, what are the values that you're getting, to some different kind of like representation to find out the pattern of the data or the new data as well. And then you can tell you need to retrain the model every now and then with the new data. And then your model will tell after the retraining based on the monitoring, hey, the new user is getting 15% discount because of his good driving of last 1 year, but the old user is getting 20% discount or 25% based on his harsh driving of last 1 year. So that's how important it is. So this is the end-to-end approach: preparing data, build and train model, deploy and predict model. So this preparing the data takes 45 to 50% of the time. Building training model takes 25 to 30% of the time. And this deploying and predicting model takes 15 to 20% of the time in the overall approach. Okay, now the question is, you got to know about the AI like team roles, AI market, and what is the AI application development life cycle looks like. Now, what is the market trend is happening in North America? So there are four types of trend that we have noticed in North America. First one is platform as a service. So just like Amazon, Microsoft, Google, and at the same time like different kind of like automobile platform, Kepler, Data Robot, Data IQ, H2O. So what they do, so we know about the like Amazon, Microsoft, and Google and their like cloud platform. But at the same time, what they're doing, we're hosting our web application, our data over there. But they're also giving us the opportunity or the extra facility of hosting our model, doing lots of training in our of our model and of our data on that kind of platform, and they're offering it as a platform as a service to use Amazon or Google automated machine learning platform or something like that. So this platform as a service is the first like trend that we have noticed in the market that a lot of companies are following. The second one is AI model as a service. So again, those three companies, my Amazon, Microsoft, and Google, they found out they came up with some of the three like key like approaches of AI or use cases based on vision, speech, language, knowledge, and search. They find out like maybe 25 to 48 use cases of basic use cases, and then they have trained those model and then hosted them. So why AI model as a service? As a small business owner or someone who has like a small web and mobile application, you don't need to like do those things like just for like a facial recognition model. You don't need to do it from scratch. You can just like take the photo from your mobile app and then use AI model cognitive service as a service, and then send the like your photo that you have taken to that API, and that API will return it's a human face or not, how angry it is, what are the neutral, like all the like facial expression and everything, so that you can easily incorporate that one, and you don't need to like spend that much money as well of all the like basic like use cases. So AI model as a service is very popular as well. A lot of companies are using them. Third one is internal R&D and AI.
Yasir,
So, hello?
yeah, Yasir, sorry to interrupt you. We are having only 5 minutes left for ending this session.
Oh, sure, no problem.
So
Yeah,
let's make use
five
of.
minutes will be enough. Yeah, perfect. Thank you.
Yeah,
So the third one is internal R&D, where like a lot of banking and like insurance companies are actually going like because they cannot load their data, upload their data to a public cloud. They host their own R&D team, IT team to host do all the like machine learning based application designing, statistical correlation finding, like and hosting their own application as well. And the fourth one and the last one, which is custom AI application, where companies like our Australia is playing a vital role. We like make collaboration with industry partners, and then we based on their custom need, we design their approach like from scratch to find out whether it's possible or not, finding the ROI, and giving them that okay, the sense of understanding that it is possible and what will be the cost, and what will the maintenance and everything. So one of our application, like very common example that we have recently developed, for Procter one of our client. So they used to take collect information of all the products that we use daily. They used to manually save them like this, but it used to take a lot of time, a lot of effort, a lot of human effort as well. Which was costing them a lot too. But what we did, one of our custom AI application, we used a bunch of like AI models with an incorporated them with an mobile app that can take photo, and then automatically based on those AI model as a service, find out what is the name, all those like ingredients, and all the manual approaches that used to take a lot of time became was done in few seconds through this automated AI application. So this is like a very good example of our day-to-day impact and use case of AI that we are doing. So, and another thing that I want to mention before I finish, my presentation, what we have noticed that a lot of companies are doing just research, not the product development. So finding the return on investment is very important in this AI industry. That's why not all kind of like cool ideas are end up in production and makes money. So you need to find out if you're thinking to design AI application, you need to design a small POC, proof of concept, so that you test early and fail early, and you can also like come up with like, okay, this application is gonna cost us $10 to develop, but the return on investment is $2, so it's not like valid, or like it's not like reasonable to build it. But at the same time, you need to be strictly ethical and unbiased in case of AI when you are designing it. And from the first day of development, you need to have a production ready mindset, so that the moment your model is ready, you can put it in production. So that's how we design our AI applications. And again, you can do lots of research, but you need to incorporate your research as a model with your mobile, web, or cloud applications. If you don't do that, then there is no value of that research if people cannot use it. So custom AI application, like these are the six things that you need to like keep it in your mind. But other than that, like if I had time, I would have like talked a bit more about our like in-house AI product, which is Workplace AI and ID for construction project management system. So as I have just a minute left, so that's it. Thank you for attending my talk. I hope it was useful. I tried to cover AI market trend, what is happening, all the best cases, like how the market is evolving, and where you are using AI in your day-to-day life. If you have any question, shoot me an email or connect me on LinkedIn or Twitter. Thank you.